Good morning, Honors Math 3, or good afternoon. Welcome back from spring break. I hope you had a good break. I wish we were all back together, but we'll make the best of this. We'll do the best we can with the situation we have. If you've noticed, we're right in the middle of Module 7, which is sequences. It's not a terrible module to work through on our own, just because it's a lot of formula type things. These are the formulas we saw so far. By the way, on your assignment on Skyward today, I attached all the handouts we'll need this week in case you need help printing them, if somebody can print them off for you. Or if you can print them off at home, that's great. You don't have to print anything, but obviously it would be easier. These are the formulas we have so far. For an arithmetic sequence, we can find the nth term of an arithmetic sequence, or we can find the sum of an arithmetic sequence. Pause any time if you want to jot any of this stuff down or try on your own. The nth term of an arithmetic sequence is always the first term plus n minus 1 of those differences, where the sum of an arithmetic sequence is always the number of terms divided by 2 times the first plus the last. We also have these formulas that you should know. What's the sum of the first n integers? What's the sum of the first n integers squared? Or what's the sum of the first n integers cubed? So those are all the formulas we have so far. I want you to read this first situation and try to think about which formula you would use. Pause for a second and read. Okay, if you read carefully, we start A sub 1 is $550. Next month we plan on depositing $60 per month into your account. Please notice then that this is an arithmetic sequence, since we're adding $60 each month. So the question is, do we need A sub n or do we need S sub n to figure out how much we'll have in the bank after a year and a half of savings? It is an arithmetic sequence, but it's not the sum of the arithmetic sequence. The bank does not take your first month's amount, second month's amount, third month's amount, and add all of those together for your balance. You're simply adding $60 to what you had previously. So A sub 2 will be $610, A sub 3 will be $670, and we want A sub 18. After a year and a half of savings, n is equal to 18. So to find A sub 18, that is always the first term plus n minus 1 of those differences, and we're depositing $60. An additional $60 every month. So what is A sub 18? 550 plus 17 of those $60. Pick up your calculator and figure out what that should be. And I got $1,570. Take a moment, if you would, just as review from last week, to try to think about these sums. I will tell you that for these sums, k squared and k cubed, we're going to need those formulas. So refresh your memory on those formulas. Okay, for this first one, I know I can take out a -2. The coefficient comes out. -2 times the sum of k equals 1 to 6, the first 6 squares. The sum of the first however many squares, there is a formula for that, and that is n times n plus 1 times 2n plus 1 all over 6. So now that's going to be -2 times, for the first 6 squares, will be 6 times 7 times 2 times 6 is 12 times 13 all over 6. And what is that? I get a sum of -182 with my calculator. What was this formula? The sum of the first n cubes. And I added that to my formula list up above. Pause if you need to and find that sum. Remember, we can separate this from k equals 1 to n of k cubed minus the sum from k equals 1 to n of 5. I'll pause for a minute. Okay, the sum of the first n cubes is this, n times n plus 1 over 2, whole thing squared, and I separated it. So for the first n, that would be n times n plus 1 over 2 squared minus, this is just the sum, 5 added to itself n times, 5 plus 5 plus 5 plus 5 n times is this. And I would probably just leave that like that, because it's just asking you in general for n. There is no ending index on that one. Okay, Consider this little sequence. Find the sum of the first 57 terms, and then give a recursive formula for this sequence. That's good practice for you. I'll pause. Okay, notice this sequence is an arithmetic sequence. I'm adding 4 to every previous term. So it's arithmetic. The number of terms is 57, and the common difference is 4. So I'm going to find the sum. I'm going to find the sum, S of 57, and I'll use that sum formula, which is the number of terms, 57, divided by 2, times the first, which is -5, plus the last, which is A sub 57. Unfortunately, we don't know the 57th term, so you have to use this formula. The 57th term will always be the first term, -5, plus 1 less 56 of those differences. And the difference was 4. That gives me the 57th term of the sequence is 219. Plug that into the sum formula, pick up your calculator, and I got the sum of the first 57 terms to be 6,099. Can you pause for a second and give a recursive formula for that sequence as a quick review? Okay, remember a recursive formula looks like this. You have to tell us where to start, so the first term is -5, and then tell us what to do to get the next term. A sub n will be the previous term, a sub n minus 1, plus 4, plus 4, plus 4. And that's a recursive definition for that arithmetic sequence. Alrighty, you probably remember from Honors Math 1 geometric sequences. We'll do a quick review of some geometric sequences and how to find the nth term, and then tomorrow the sum of a geometric sequence. Anytime that the ratio of consecutive or successive terms in a sequence is the same number, then that sequence is a geometric sequence. Here's a couple examples of geometric sequences: -3, -12, -48, and so on. What am I doing? I'm multiplying by 4, multiplying by 4, and that's a geometric sequence. Or how about 12, 30, 75, 187.5, and so on. This is a geometric sequence. It's harder to find what I'm multiplying every time, but you remember in a geometric sequence, we always had a common ratio. Anytime the ratio between the two consecutive terms is the same, that's a geometric sequence. So I can always take a term divided by its previous, a term divided by its previous, and a term divided by its previous. Over here is a little bit easier. -48 divided by -12 gives me that common ratio of 4. What is that common ratio? Simplify that. What do I divide by 15? And I get a common ratio of 5/2. And you can simplify. Defined recursively, a geometric sequence starts with the first term, and then how do I get each successive term? I take the previous term, a sub n minus 1, and multiply by r. Please notice solve for r, and that ratio will always be, solve this for r, a sub n divided by a sub n minus 1. And there is to find that common ratio, any term divided by its previous. Can you take a moment and decide if these two sequences, are they arithmetic sequences, geometric sequences, or neither one? Take a minute to decide. Okay, thanks for looking. This first one is clearly not arithmetic. If I subtract 4 minus 12, that's not the same as 4/3 minus 4, so it's certainly not arithmetic. And then I move on to geometric. Is 4 divided by 12 the same as 4/3 divided by 4 for a common ratio? This gives me 1/3. What is that? 4/3 divided by, that would be 1 over, multiplied by the reciprocal, and I get 1/3. And yep, I have a common ratio. That common ratio is 1/3. And this is a geometric sequence. Geometric sequence with a ratio of 1/3. Did you take a second to look at that next one? Look for a common difference, or look for a common ratio. Difference here is 3, difference here is 5, so it's definitely not arithmetic. Look for a common ratio. Is 4 over 1 the same as 9 over 4? Those are not the same, so this is neither. Not arithmetic or geometric. Alright, let's find an nth term for a geometric sequence. Alright, let's see if you can notice the formula to find the nth term of a geometric sequence, a sub n, similar to our arithmetic sequences. we start with the first term, and then what do I do to that term in a geometric sequence to get the second term? Remember, I multiply by my common ratio, r. If I multiply by r, my next term is the first term times r. But then I'm going to multiply by r again. If I multiply this times r, it's the first term times r squared. If I multiply that times another r, that common ratio, it's my first term times r to the third. And then you start to notice fourth term is a sub 1 r to the third, third term a sub 1 r squared, nth term is a sub 1 times what? Please notice that pattern, that's an r to the n minus 1. And you can find the nth term of the geometric sequence. Find the 10th term of this sequence. Find the common ratio, always a term divided by its previous, and it's the common ratio. So the 10th term of the sequence will always be the first term times the ratio to the n minus 1. In this case, the first term was 5, common ratio is 2. I want the 10th term, 10 minus 1, which is 9. Pick up your calculator, pause, figure that out, and I got the 10th term is 2560. Okay, here's a geometric sequence. We only have one formula so far. A sub n is always the first term times r to the n minus 1. You're asked to find the 10th term if you know the third and the sixth. So the 10th term is going to be the first term, whatever that is, times the ratio to the 9th. So we need to find two things. We need to find the first term, and we need to find the common ratio. Think about going from the third term to the sixth term. How many ratios would that be? Multiply to get to the fourth, fifth, and sixth. That would be 3 of those common ratios. I'm going to plug into this formula, and I'm going to say, oh, how about this? The sixth term will really just be the third term times the ratio to the third power, 3 of those ratios. So now I can solve this, and I'll pause. 25 halves is equal to the third term, 1/10, times the ratio to the third. Take a second and try to solve that. Okay, I multiplied both sides by 10 to get r cubed by itself. Simplify, that's 125 is equal to r cubed. I can take the cubed root of both sides, and I see the common ratio is equal to 5. Okay, come back here. I want to find the 10th term, which is always the first term times my ratio of 5 to the 9th. All right, clearly now we need a sub 1, so now we need to find a sub 1. Let's do something similar to that. I'm going to use a sub 3 and say a sub 3 will really just be a sub 1 times my ratio twice. Plug in what I know. A sub 3 is 1/10. I need to find a sub 1. We found our ratio is 5 squared. Take a moment and solve for a sub 1 if you would. Okay, see if you agree that when I solve for a sub 1, multiply both sides by 1 over 25, I got 1 over 250 for a sub 1. And then to find that 10th term, please multiply all that out. I get 7812.5. I'm almost out of time. I'm going to ask you to try this next one on your own, and then I'll walk through it and see what you get before your assignment. Alrighty, take a moment on that next one for practice. Okay, using my a sub n formula and going from the 6th term to the 10th term, that would be 4 of those common ratios. I plugged in and solved for r. I got r is equal to 1/2, my common ratio. Now to find the 15th term. A sub 15 will be the first term times our ratio, which is 1/2, to the n minus 1, which is 14. Now I'm going to give you a second, if you would, to find the first term of this sequence. Okay, see if you agree. When I found a sub 1 using the 6th term with 5 of those ratios, I get a sub 1 is 128. And now plug into my formula to find the 15th term is a sub 1, 128, times my ratio of 1/2 to the 14th power, and I get 1 over 128, unless you wrote that as a decimal, of 0.0078125. Nicely done. Alrighty, if you could tonight, try on worksheet 7-3, numbers 1 through 9, if you would. Just the front of that worksheet. It will be due by the end of the day, midnight on Tuesday. Alrighty, see you tomorrow. Have a great day. Bye-bye.